Hello and welcome to the BioPhorum Plug and Play seminar. Thank you for holding on for a couple of minutes. We just wanted to make sure people had the opportunity to get online, but we were ready to go. So my name is James Colley and I'm a facilitator with BioPhorum. For those of you who may not be familiar with our organization, it's a company who creates an environment where a global biopharmaceutical industry can collaborate and accelerate the rate of progress. So it's for the benefit of not only our members, but the community as a whole. Today's webinar comes from one of our teams, the Plug and Play team, who've been working for over 2 years now to develop improved interoperability to flexible facilities. I'd like to say many thanks to you, to those of you who were able to fill out our survey beforehand. If you do have an opportunity and feel comfortable during the talk, then we're going to pop a link to that survey in the chat. Thank you, Nettie. And as we go through the presentation, of course, you'll have the opportunity to submit your questions. We have a panel of experts who've been working from within the project. And what we'll try and do is, where appropriate, we'll answer those questions individually by writing to you. And some of those questions may get raised up at the end in the Q&A session with the panel. The results of so comments from the questionnaire, as well as questions that come through in the session, will go to that panel, and I think that's about it. That's ready to go. So it just falls to me to introduce our speakers today. So Kelsey Hill is the Life Science and Marketing Manager from Emerson Automation Solutions, and we have Bruce Kane, a Life Science Industry Consultant from Rockwell Automation. So Bruce, if you're ready.
Thank you very much, James. Good day, everybody. How are y'all? So what's the problem that we're trying to solve with this plug and play standard that we're talking about here? Well, actually, let's back up one. I guess I jumped ahead a little bit. Let's first talk about what we're going to talk about. So we're going to begin with what the problem is, and then we're going to talk a little bit about who BioPhorum is, talk about what our initial concept was, and then we're going to talk about 3 demonstrations that we've had planned, 2 that we've already had, and 1 that we're having in September, and then we're going to do a quick summary to wrap up everything with a Q&A for the panel, and then the survey results that James spoke about also. We're going to talk about this. So what's the problem? Well, we need, and there's a lot of F's in this sentence, flexible facilities need flexible automation to fully enable flexible manufacturing in the facility of the future. Right, and that's from Pharma 4.0. And basically what it means is that we need to be able to more easily interchange and modify our facilities and our systems to make different products more quickly and with less expense. So what are some of the issues that we're experiencing now that lead us to think that we need to be more flexible? Well, presently, we have an inability to easily switch unit operations and their technologies. So that means we can't easily utilize vendor A's bioreactor skid and vendor B's bioreactor skid with the same configuration. And we can't swap them out with the same recipe and utilize the same recipe that utilizes those 2 unit operations. So it limits our flexibility to utilize equipment from different manufacturers. It also necessitates additional time to custom engineer the interfaces to these systems. A lot of times, a particular vendor of a skid may not offer your your preferred vendor's control system on their skid. And so there's an additional cost to re-engineer that configuration to work with your preferred control system. And that's a unique development effort. Every different system that you want to talk to that's on a different platform, you're going to have to re-engineer that configuration. Even the same type of unit on different manufacturers' skids is going to have a different interface, because the way that they chose to, run a dissolved oxygen phase and the parameters required for that are different. There's also an additional cost to the maintenance and operation of these bespoke and custom systems. Your operators need to be trained and a lot more deeper level of understanding of the system to try and re-engineer these custom configurations, rather than if they were working with a more standard configurable interface. So where would these changes need to happen? Excuse me. What would have to change in the way that we're doing things now to support this more flexible, this more modular way of doing things? Well, we move away from a custom variable software architecture towards a more standard and interoperable one. One that utilizes off-the-shelf standards, industry standards, international agreed upon ways of functioning. You move from customized or vendor-specific communication protocols to industry standard protocols like OPC-UA. You move away from custom and unique control modules and device layer interfaces toward a more reusable configuration with a defined set of control module types and configuration parameters. You move from having customized configuration and recipes at each scale to having reusable modular pieces that can be used at multiple scales, because that's the way they're engineered. And makes it easy for that knowledge transfer to roll out that next production line when it's more modular and flexible. It becomes just another instance of the configuration, rather than at best a copy paste exercise. And the ability to interface to the system becomes greater. You're not tied into your original system providers or only certain system providers. You're able to interface and connect with multiple suppliers. So what are the advantages that you get by moving to these types of configuration and practices? Well, your deployment and reconfiguration speed becomes quicker. It becomes cheaper to do things. You become more flexible because things are modular and multiple vendors' units can be used in the same recipes or on the same lines. Your information becomes standardized and more valid, more robust, and probably most importantly, and what probably has the greatest effect on your ability to quickly roll out a new plant or a new line, is the reduced testing and validation effort that you get from an effort from a standard like this. You basically move that effort, that testing and that validation away from the end user and over to the OEM equipment supplier. So let's look at what this means for each different personas, different personalities will have different benefit from these efforts, from the standardization. So let's look at how different people might benefit. So equipment vendors get a more standard offering. They're not having to continually re-engineer their system for a different controller because a customer wants a different controller to host the system. For supervisory system vendors, control system vendors, you gain the benefit of increased compatibility. You can talk to more things. You can be used in more applications. For integrators, they're not always having to create custom interfaces, right? It's configuration, not customization. And probably mostly related to the reduced validation effort, but certainly we'll see there's savings in a lot of areas, and the users get a faster time to market at a lower cost, which is really important now, especially as we're trying to spin up production capability for a potential vaccine. Estimated cost savings one might expect from implementing a standard approach such as this. Now, this is per instance, and these are rough estimates. I think it might be nice in the future for us to develop sort of a total number for a skid, but the numbers that we've been able to come up with thus far, are quite significant. I mean, just to develop a new interface, a lot of times you're talking, 3 months to do something like that. Plus you have to, create new custom diagnostic and help tools to manage the system, and that's usually an additional effort. It takes a few weeks, and then you got to troubleshoot communications and come up with workarounds, diagnostic times, and then on top of all of this, and we don't even have it here, is you got to manage and lifecycle manage all that configuration you've created. So there's significant savings both, on the front end and throughout the life cycle of the control system from following a standard approach such as this. So with that, I'll pass it over to Kelsey to let you know about who BioPhorum is.
Yeah, hi everyone. So James kind of gave a real quick brief overview of who BioPhorum is. I'm going to go into a little more detail here. So who are we, and what exactly are we working on to solve this? So BioPhorum is a global industry collaboration with 7 different forums where people are working together. We've brought together industry leaders and experts across the industry working on over 60 different initiatives to try and deliver results by pooling knowledge, practices, and ideas. And you can see some numbers there. We've got quite a lot of participation and work going on here. So membership in BioPhorum includes both people from the top biopharma manufacturers here, as well as people from the industry supply partners working on the technology development. So we've got a good mix across both of those. For the 7 different forums mentioned, we're specifically part of the technology road mapping forum. which is focused on, how can we change and transform the way we do manufacturing with the technology that we have? What can we do in the future? What do we need to get that done? So a little bit longer timelines. How can we truly move on to the next big thing, as opposed to some of the other forums that are working on more, how can we do stuff now? What are best practices we can develop now to deliver results today? We're focused more on where are we going and how can we get there and make it easy for everyone to do that. So that's kind of some of the differences there. Also with BioPhorum, we get connections between with the regulatory stakeholders and the dedicated facilitation, which allows us, make sure things keep getting done, but also make sure we can link across the forums as needed. And we've done that several times with our group as well. So for the technology road mapping, these are the specific manufacturer, supply partners, and engineering partners that are participating in this forum. We have a steering committee that's more focused on the strategy and influencing from the various members, what is the actual direction we should go, what are our priorities. And then we have the individual project teams with the various experts that are actually working on how do we deliver these solutions to these technology challenges. So for those projects, we're specifically the plug and play team. You can see some of the other ones here. So again, focused on working for a solution to the problems that Bruce mentioned, publishing white papers, developing standard frameworks, and implementing and doing several proof of concepts to show what we're coming up with is working. So specifically for our group, we have, again, members across the system vendors, module vendors, the end customers, and the EPCs as well. So this is our team of people here. So that's just a little bit about BioPhorum and kind of how we fit in and where we fit in there. I'll hand it back to Bruce to kind of start off with some history on where we started with our initial solution for plug and play.
Thanks, Kelsey. I appreciate it. So in the beginning, the concept that we started with, and this was presented to BioPhorum initially in 2017. I think they had the first team meeting of the work stream in Germany in the fall of 2017. And basically what was presented is a method to abstract a bioreactor or skid from the control system that's driving it. So basically a way to present the configuration and capabilities of a piece of equipment in a standard way to a process control system so that it can be used in a standard way within a phase for the piece of equipment within a recipe. And excuse me, if we look at how we sort of broke that up and segregated the different pieces, we started off with the S88 batch model and the two different hierarchies, the physical and the procedural hierarchy, and we tried to segregate them as far as who had responsibility for which parts of the hierarchies. And what we seemed to agree on was that, the skid controller, the OEM vendor, controls the stuff associated with that piece of equipment, right? The control modules, equipment modules, the units, and really the phase definition over on the procedural side. They control what the stuff can do, whereas the supervisor control system or the end user is going to decide how to use that equipment, right? What is the procedural? What does that look like in their overall methodology of doing things? How does it fit in their operations? How does it fit in their unit procedures? How does it fit in the procedures? and ultimately how it fits in their process cells, right? They decide whether or not to include that piece of equipment. And looking at the segregation of responsibility in this way led us to the observation that we could also segregate the testing and validation of this equipment in sort of the same fashion, so that suppliers could provide a coat skid, if you will, right? A standard, pre-validated, pre-tested piece of equipment that could quickly be integrated into a user's procedural tests and be leveraged in a validation effort. So based on this proposal and this vision of how to sort of lay out the standard and segregate things, the work stream began, like I said, in late 2017. We've so far written the white paper, and we've decided on the first 3 units that we're going to write the standard for. So a stirred tank unit, which includes bioreactors and a few other classes of vessel, chromatography units, and normal flow filtration. Of those, we've already agreed on the bioreactor data model, and we've actually had 2 proof of concepts related to that bioreactor data model. And through those proof of concepts, we've begun a collaboration in Emerson that happened last year, and we started to develop some governance models as well on how to manage the standards. Hopefully, we will be releasing the stirred tank unit interface shortly, if we haven't already. I know it was out for approval internally within BioPhorum. So that might be something you want to look for in the future. So with that, let's talk a little bit about the actual tests we did with actual equipment and wires and stuff. And so I'll pass it over to Kelsey to talk about the first one we called a Plug Fest.
Yep. So the first proof of concept we did, we called Plug Fest, because basically we brought all 6 suppliers into a room and basically had everybody plug their equipment into one network switch, and ran our tests from there. But this was held in November in 2018 in the UK. We had 3 PCS suppliers and 3 skid suppliers. You can see here. Our focus was on bioreactors, specifically a single-use bioreactor, and we had come up with 2 phases to use for our test. I believe it was an inflate phase and a media transfer phase, just to prove that we could run the same phases with the same parameters on each combination of PCS supplier and skid. So we ended up with 9 different tests. We had our 1 data model for our phases, and then all across 1 network. And so we did that over the course of a couple days. So kind of what came out of that was we were successful. Everybody was able to connect and run the 2 phases. What we did find, we did have some challenges around the tag naming, making sure everybody's were exactly the same. We had parameter names the same, but like the full addressing wasn't consistent between the different suppliers. So that was just a challenge to resolve. And kind of out of that, we realized, we're the experts. We have the expertise around defining the data model for the unit operations in biopharma, but that the developing an interface standard specification for like the communication side of things wasn't quite our expertise. So we decided to see kind of what else was out there. Was there an existing standard that we could leverage for our data model? So we could focus our efforts on the data model definition and then just use an existing standard for the communication layer. So we took some time and looked at what's out there and kind of what we came up with was we looked around or found out about the MTP or the module type package. So basically, we'll see. We start kind of with the technology stack. Everything's going over Ethernet, TCP/IP. We're all using OPC UA. That's kind of one of the enablers for the plug and play concept. But what the MTP brings is this kind of layer here for the framework. So it provides the state model, the various services, the way to handle parameters, the way to handle communication specifically for the various services that are out there. So this was kind of the missing piece that we didn't want to develop if there was something else out there, and there is. And while we were looking, there's other groups kind of trying to solve the same problem. The ISPE plugin produce team is also working on a similar concept. They're aligned with the MTP direction as well, except they're kind of focused more on some of the GMP requirements there, and possibly on some secondary units. Whereas us in BioPhorum, we're focused on the functions and profiles for the specific biopharma equipment, like Bruce mentioned, the bioreactor and various stirred tank unit classes, chromatography, and various flow filtration. So that's kind of where we came up with what our place was in this problem space, and how we could best contribute. So if you're not familiar with MTP, here's a little background on what that is. It came out of a recommendation from the Nomura group in 2013, followed up by a white paper from the ZVI group on modular automation. They've released, in 2017, released their first part of the standard, and you're starting to see there's MTP in some pilot plants as of 2018. And it's a collaboration, again, among all the top industry companies in this space as well. So what is MTP specifically, or what does it mean to do modular automation? Basically, the concept is, and it's one of the big enablers for plug and play, is that on the module side or the skid side, they can define their piece of equipment and all of the available services and parameters and needed things to run it. And that information can actually be exported into a file, an MTP file that contains all of that information, including HMI graphics and so on. That file can then be imported at the process control level into your PCS system. And then your PCS has the information it needs, and it can run its control from there without having to build these specific interfaces. All of that information was brought in with the import of the file. So you can pull in the different modules as needed. If you need to swap one out, all you have to do is import a new file, and you can theoretically run your same or very similar configuration process with limited and configuration changes on that side. So that's what we're looking for and what that gives us. So what Nomura and the VDI group has come up with so far is they're releasing this standard. They have the first two parts, page 1 and page 2, which define the general concept, and then the HMI stuff is out and available for use. That was in the last couple years. The next two parts are for the actual object types, and then the services, or what we might consider phases. And those are targeted to be published this month, as far as I'm aware. The white print for the part 3, and the green print, which is kind of a draft for comments for the services side of things. And you can see the full list of everything else they're working on. The ones I've highlighted in yellow are where we actually have a working group collaboration within BioPhorum. So we have teams or sub-teams in our group working on the alarm management and the validation pieces, and collaborating and providing our recommendations and work to the Nomura group to be used in the standards. So that's kind of how we're all working together to try and bring this about. Okay, and with that, Bruce, if you want to talk about what we did for the next one.
Sure, thank you very much, Kelsey. So based on the learnings of that first test that we held, you know, we went and searched, and we found Nomura and the MTP standard rather, and so we decided for our next test to sort of focus on the implementation of that. So you take the bioreactor standard definition that we developed in the first proof of concept, excuse me, and use it with MTP to transfer the configuration between the systems and graphics, and handle the services interface, the phase layer interface, the integration layer between the two systems. So the second proof of concept that we did, focusing on MTP, we had 7 participants, same 3 process control vendors, Emerson, Siemens, and Rockwell Automation. And on the OEM vendor side, we had Merck, Millipore, Paul, Sartorius, and a new participant this go round, GE Healthcare. So we did all the permutations and combinations of connection and interface, a total of 12 different tests, all utilizing the single data model of the stir tank reactor, single-use bioreactor. And we all shared a common network, TCP/IP layer, and we used OPC UA to handle the communication between everybody. So what did we learn from this, second effort at trying to integrate equipment easily? Well, we learned that the interface with NTP was a good one, and that it was functional and useful. We also were able to establish a relationship with the Emerson group, and we began actually collaborating with them on a couple of the standards that they're writing. So alarms and audits, we're helping write those. We also were able to make a couple proposals to the group, and actually got one of them implemented. We made a proposal to more closely follow the S88 to find initiation for a hold state, rather than the way they were proposing. So that was another learning that we had out of it. One learning that we had that was pretty basic and almost a little embarrassing is all the vendors weren't working off the same copy of the standard. So since the standard was still being written and still in flux and change, not everybody had access to the same version and were able to conform at that level. So there's some minor little tweaks that we had to adapt to accommodate that sort of basic project execution method. And we also learned that we were on the right path with our service model for the units that we identified, and we continued our effort there and updated our documents to more closely reflect the NEMR terminology and the NEMR methodology and standards. So let's talk in a little bit more detail about what these specifications, these standards that we're creating are. In our white paper, we identified 5 unit operation classes. The first 3 we're actively writing the standards on. And the second column there, you see the unit class types that fit in that unit operation. So a stir tank class would include 5 different types of equipment, potentially. A stir tank, single-use bioreactor, a rocking single-use bioreactor, a single-use mixer, used for multiple functions, right? Auto filtration techniques for virus inactivation, and potentially more. We're looking at, additional ones that might fit in there. So the idea is that this would be an evolving standard. Quickly talk about our schedule and the work we're working on right now. So you see the work, whoa, on our stir tank unit, the chromatography skid. You also see the work streams in here where we're working with NMR regarding the audit trail and alarm and events. So just a Gantt chart presenting all that. We'll be working on this well into 2021, we believe. So continue to look for output from us on additional tanks and unit classes as we proceed. Talk a little bit more about this stir tank interface specification, and look at it as sort of a model for the other classes that we'll be defining. These documents will be segregated into two pieces. The first half is going to be sort of the general assumptions and sort of guidance overall for this class and for these types of documents. And the second half of the document will be a specific definition of all the services and the parameters and really the nuts and bolts of the implementation of this interface. If we look at the services that we've currently identified, we've identified a total of 10 different services, and the application of those services may be different slightly depending on the particular class that you're implementing on. So probably the easiest example to point to would be the stir tank versus a rocker. One would have an agitator control service, and the other would have a rocker control service. And another example might be, auto titration control, which wouldn't be necessarily applicable in a single-use bioreactor, but would be in a buffer prep or virus inactivation application. So with that, I'm going to pass it back to Kelsey to take you through the rest of the presentation. Thank you very much.
Great, thanks, Bruce. Just a few more slides here. So next up, what we're planning to do upcoming for our next demonstration, we want to run that full STU spec on real equipment, and just to prove out, demonstrate our models are accurate and useful and what's needed to run an actual piece of equipment. Since we've already kind of proved the concept pieces beforehand, this one would be more focused on the actual specification that we've developed. The plan is right now is for it to be held in September, and it planned to be held virtually with all the stuff that's going on. So we are also doing work on setting up a BioPhorum VPN, so all the various suppliers can connect their equipment to that, and we can actually run some tests virtually, and we don't need to all be in the same room together. There's a few other prerequisites before we actually get here. We're still waiting on those two NMR pages or documents that were planned to be released this month, so we can actually develop against them the accurate ones as lessons learned from our last time, and then getting the VPN and some of the alarm management stuff set up before we get moving. But that's the plan, and if you're interested, reach out. We're always looking for new people, but that's what we're working on next. Just to wrap up a little bit, we have released a white paper we've referenced a couple times. It was published in Bioprocess International. I think it's the October edition of 2019, and it's available on the BioPhorum, also available on the BioPhorum website if you're interested in looking for it. Okay. Just for a quick summary before we get to our Q&A panel. Some key takeaways. So we're the BioPhorum operations group working on a plug-and-play standard and data models for single-use equipment. We've had our white paper published. Okay, might have been the November issue, one of those two issues. of the Bioprocess International. Completed several proof of concept tests. We're in the process of finalizing our data models for review and publication. Our STU is complete and it's in internal review, so it should be available shortly. Our data models are being used within other BioPhorum work streams internally. We have linkages with the buffer prep group, the big data group, and the continuous downstream processing group. So starting to see some good interest and adoption across BioPhorum. And again, overall, the benefits of doing plug and play, you get benefits in speed, cost, flexibility, and quality from having a standardized solution. And again, always looking for new member companies and volunteers from existing companies. If you're interested, please reach out. We would love to have you.